In this video, we're going to take a look at definite integrals. Just remember that all the rules for definite integrals are the same as the rules for the indefinite integrals, that now we're going to evaluate it. And the fundamental theorem of calculus is what we're using to evaluate it. So the fundamental theorem of calculus says that the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. So we're going to use this to evaluate these integrals. So the first step is the same as the indefinite integral. I'm going to write this integral as in a way that I can use the power rule. So I'm going to say 3 times 1 to 4 of x to the 1/2 dx. And now I'm going to use the power rule. So I have 3 times x to the 3/2 divided by 3/2 evaluated. So now we put the evaluated bar instead of the plus c, and then from 1 to 4. And now I'm going to simplify my constants. I have 3 divided by 3/2, or 3 times 2/3, which gives me 2. And then I'm going to have x to the 3/2 evaluated from 1 to 4. And when we evaluate, we're going to do the top number minus the bottom number. So it's going to be 2 times 4 to the 3/2 minus 1 to the 3/2. And now 4 to the 3/2 is equal to 8 minus 1. So we have 2 times 7, and that's equal to 14. In this next example, I have the integral from 0 to 1 of x times x squared plus 2, all raised to the 3rd power, dx. So we have a U-substitution problem here. So we're going to choose u to be equal to x squared plus 2. du is equal to 2x dx. And then I'm going to rewrite it as 1/2 du is equal to x dx. And now let's take a look at our substitutions. So we have x squared plus 2 getting substituted for u. And we have x dx getting substituted for 1/2 du. And now let's rewrite our integral. And for the time being, I'm going to not put our limits of integration because we need to talk about changing those. So what we have here is u cubed du, and the 1/2 I'm going to put out front as a constant. Now in our original problem from 0 to 1, these are x limits of integration. And now when we change it to the u variable, we're going to change our limits of integration as well. So we do that by plugging it into our u is equal to x squared plus 2 function. So when I put 0 in for x, I get 0 plus 2. So now my u limit of integration is from 2 to 1 squared is 1 plus 2, 2 to 3. And this makes it more convenient at the end of the problem because we don't have to change our integral back to x after we're done. So here we have 1/2 u to the 4th over 4 evaluated from 2 to 3. And again, I'm going to combine our constants here, and I'm going to say that 1/8 and then u to the 4th evaluated from 2 to 3. And now I have 1/8 times 3 to the 4th minus 2 to the 4th. And then we can calculate that. I get 1/8. 3 to the 4th is 81 minus 16, which is equal to 1/8 times 65, or 65/8. And that's all for the definite integral.